Good morning, scholars. Today we're going to be talking about chi-squared tests of homogeneity. Now, just to review, there are three types of chi-squared tests. One is called the goodness of fit. That's like the M&M's activity we did in class. Today we're going to be learning about a chi-squared test of homogeneity. And there's also another test called association independence, which we will learn about later. And just to see the difference between them, a chi-squared goodness of fit test looks at one variable in one population and sees if that population fits a claimed distribution. So that example is like the M&M's example, where our one variable was the color of M&M's and our population was all M&M's everywhere. So we are trying to fit a claimed distribution. Today we're going to be talking about a chi-squared test of homogeneity that looks at one variable in two or more populations. And we did do one example in class where we talked about Snapchat habits, which was our variable. So the one variable is Snapchat habits, and the two populations were scholars at Del Lago and scholars at Escondido High School. So a test of homogeneity sees if the sampled populations are alike each other in their distribution of a single categorical variable, such as Snapchat habits. And then the one we will look at later, a chi-squared test of association, looks at two variables in one population and sees if they have some sort of association with each other or if they're independent. So an example we'll do later about that, it has to do with sports played and math class taken. And that will happen later. Okay. So now remember, for all of these, you use the same chi-squared statistic. It's the sum of all the observed values minus the expected values squared over the expected value. And basically what that means is we find the difference between observed and expected, and we have some sort of way of measuring how strong that difference is, how far off the observed is from the expected. Okay, so the chi-squared test of homogeneity is sampling from each of two or more populations, and each individual is classified according to a single categorical variable. And basically, I'm going to look at the distributions to see if the two population distributions is the same for all my sampled distribution or all my sampled populations, or my HA is the distribution different for some of the populations. So notice that H naught on all these chi-squared is basically, is it the same, or is the distribution the same as the claim distribution? Is it no difference? And the HA is there some sort of difference? Notice again that our hypotheses are written in words instead of numbers because we're talking about categorical variables here. Okay, we're going to skip that one for now. Chi-squared test for homogeneity example. So, market researchers suspect that background music may affect the mood and buying behavior of customers. One study in a European restaurant compared three randomly assigned treatments. They either had no music, French accordion music, or Italian string music. Under each condition, the researchers recorded the number of customers who ordered French, Italian, and other entrees for dinner. Here's a table that summarizes the data. And what we want to know is there sufficient evidence to show that there is a difference in the distribution of entrees ordered that is somehow influenced by the music playing. Okay, so take a screenshot of this and just look at the data and give your sort of initial reactions to what you think we might find when we do this statistical analysis. Okay, so using the template, we have our H naught and HA, and our H naught is going to be there is no difference in the true distribution of entrees ordered at this restaurant when different types of music are played. And HA is there is a difference in the true distribution of entrees ordered at this restaurant when different types of music are played. Okay, now remember to find our degrees of freedom for a two-way table. We have a little bit different formula. It's going to be the number of rows minus 1 times the number of columns minus 1. So in this case, remember, you do not count the totals as part of your rows and columns. Those are just to help us with our calculations. So we've got 1, 2, 3 rows and 1, 2, 3 columns. So I'm going to have 3 minus 1 times 3 minus 1, which equals 2 times 2, which means my degrees of freedom for this will be 4. We want to conduct a chi-squared test for homogeneity because I'm trying to see if this these two or actually three different variables in the populations are going to be the same. So that's the test of homogeneity. And it's at an alpha level. We'll just choose the default of 0.05 since it wasn't given to us. Okay, so we need to find all the expected values for each of these pieces in our table. Okay, so the formula to find each of these is going to be, so our expected will equal our row total times our column total divided by your total. Totally. All right, so for the French entree with no music playing, that's in row 1, column 1. So I'm going to look at the row total, which is 84, times the column total. Oh, I'm sorry, that was the column total. Apologize. So the row total, which is 99, times the column total, which is 84, divided by the total, which is 243. When you do that, you should get 34.22. I'm going to go ahead and write in all of the different expected numbers, but you should try to do at least some of them on your own to make sure you understand how to do that. Now, as you're getting these in here, you can already kind of see which components might be larger because they might be more off. The observed and the expected are more off of each other. So just kind of analyze that before you even do your full statistical analysis. Okay, now that we have our observed values and our expected values all in there, and we have our degrees of freedom, we can go to the do part of the significance test. So screenshot this or write it, pause and write this all down. Actually, we're going to do our plan first. So the conditions checks are pretty easy on here. This was a random assignment. So notice that this was actually a experiment. So they randomly assigned treatments. So the music was the treatments. Large sample size, I need to check my expected values. That's one reason why you need to write down. You don't necessarily need to write down every single one of the expected values up here in your table, but you have to show some sort of formula like I did on one of them to show that you know what the expected values are and you know how to find them. So all the expected are greater than or equal to 5. And you can see that back again in the table. You can actually, one way to do this too, if you're taking the AP exam, find your lowest expected value, and if that one is greater than 5, then you're good. So my lowest expected value is 9.57. So you can say something like lowest expected is 9.57, which is greater than 5. So that way you can say if the lowest one's greater than 5, then they're all greater than 5. So the independence check, basically I'm looking at a sample size of 243. And we're going to assume that a busy restaurant has more than 2,430 entrees purchased. So busy restaurant. Okay, so those are all our conditions checks. So now we can move on to the do. Okay, so remember for any chi-squared test, our formula is the sum of our observed minus expected squared over expected. So if we go back to the table, we can see for the first row, first column, my observed is 30. My expected is 34.22. I square that and divide by the expected. Going on to the next one, I have 39 minus 30.56 squared over 30.56. I'm not going to show every one of them, so this is like dot, dot, dot. And you can do this too when you're showing your work, either for your comp or for the AP exam. You don't have to show every single one, just to show that you understand how to calculate it. And then once we get all of those added up, we get 18.28, which is quite a large chi-squared statistic. So our chi-squared is 18.28. Our degrees of freedom from before is 4. So if we draw that on here, 18.28. And with chi-squared, we're always looking at going to the right, so greater than. So if you look at our calculator command, we get chi-squared CDF. We have a lower bound of 18.28 and an upper bound of technically infinity, but we put 99999. So that's our lower bound, that's our upper bound, and this is our degrees of freedom. We ended up with a p-value of 0.001, which again is a pretty low p-value and a pretty high chi-squared. So notice that sort of inverse relationship between those two. Okay, so we have a p-value of 0.001, which is definitely less than our alpha of 0.05. So we're in this category. So that is strong evidence, and it is statistically significant, and we will reject H naught. So I already started the conclusion here, but what I want you guys to do is pause this and without looking, try to write the conclusion on your own, or at least part of it, before you look at this conclusion. I'll hide it for a sec. Okay, so pause the tape and try to write the conclusion on your own. All right, here's the conclusion. Assuming H naught is true, there's no difference in the distribution of entrees according to music played. There is a 0.001 probability of getting a chi-squared statistic of 18.28 or higher purely by chance. This is strong evidence against H naught and statistically significant at alpha equals 0.05 because the p-value is less than alpha. Therefore, we reject H naught and conclude that we have convincing evidence of a difference in the distribution of entrees ordered, which can be attributed to the music played since the treatment of the music was randomly assigned. Now, in addition to the regular conclusion, you should also state something about which component contributed to the high chi-squared the most. So if you look back at all your calculations, the biggest component that I found was when Italian entrees were ordered and French music was playing. Only one person ordered that. And that gave us a component of 7.67 when we took our observed minus expected squared over expected. So I'm going to write a little bit about that. I'm going to say the largest component to contribute to the high chi-squared was Italian entrees ordered when French music was playing. At 7.67. Okay, and then in a close second, it was 6.4 for Italian music with Italian entrees. So usually you have, if you have something that's lower than expected, you have another component that's higher than expected. So we can also say also 6.4 for Italian music with Italian entrees. So evidence would suggest that Italian music has more influence on entree orders at this restaurant than other types of music. Okay, now notice I say at this restaurant because that's our population. We cannot use this evidence to say that it would be true at other restaurants. So be careful with that. All right, I will leave you with poor little skewed to the right, chi-squared. He just wants to be normal. Don't we all? Bye, guys.